So hey, what is up guys, this is Naveen here and welcome back to my channel, and today we are gonna solve a Code Chef Made Challenge 2021 division rated 3 problem named as XOR equality, and if I rate its difficulty level it will be around 50 to 60%, and it is a quite difficult problem. I will let you know why. So without wasting any time, let's get into the video. But wait, if you are new to this channel, please make sure to subscribe my channel and hit that bell notification icon so that you can get notified for my upcoming amazing videos. So let's dive into the video. So as you can see, we have to find number of ways to choose an integer from the range 0 to 2 raised to power n minus 1 such that it satisfies this condition where this element denotes the XOR operation, and we have given this line too. Since the number of valid x can be large, output it modulo 10 to the raised power 9 plus 7. I will let you know why it is given to us. And moving into our input part, we will be provided our integer t, which will be denoted as number of test cases, and we will be given our integer n, where n will donate the power of 2. So I think so you have got the idea what we have to find, but it is a quite confusing statement. I will try to make it simplify for you. So let's get into a PPT mode. So as you can see, we will be given the value of x, which means this n value, and it can vary from 1 to 10 to the power 5, and that's a pretty big number, which means the time complexity can be of n square, which is the worst case complexity, and the best case complexity can be O of n or O of n log n. So as you can see, I have taken 6 input here, which will vary from 0 to 6, and here I will be checking this expression for each integer. So let's begin. If I input the value 0, the binary representation of value 0 is this, and 0 plus 1, which means 1 representation in binary, is this. And if we apply XOR operation, then the resulted output will be this. And here is the answer for our this statement. Now moving up to this statement, which is x plus 2 XOR x plus 3. If I add 0 plus 2, it will be 0, and the representation will be this. And if I add 0 plus 3, then the representation will be this. And if I do the XOR operation, then the resultant, so as same, if I input the number 1, the binary representation will be this. The binary representation of 1 plus 1, which is 2, will be this, and the XOR operation resultant will be this. Okay, and 1 plus 2 binary will be this, and 1 plus 3 binary will be this, and the resultant XOR operation answer will be this. And same as for these 5 input too. If you don't know what is XOR operation, it is basically, you can see over here, if the first input is 1 and the second input is 1, then the resultant output will be 0. If the first input is 1 and the second input is 0, then the resultant output will be 1. If the first input is 0, second input is 1, then the resultant output will be 1. If the both input is 0, then the resultant output will be 1. So from this we can say that if the both number are same, then the resultant output will be 0. If both number are different, then the resultant output will be 1. Okay, so as you can see over here, we can find a pattern over here in which when we input the number 0, we got the output this, and these two matches each other. When we input the number 1, we got different outputs, and these are not same, so this doesn't satisfy this condition. And if we input number 2, we got the same answer, and so on for 4 as well as for 6. So as you can see over here, the number which satisfy these condition is always a even number. You can see 0, 2, 4, 6, and so up to 8, 10, 12, and so on. Okay, so from this we can conclude that if we take the input as 2, that means 2 power 2, which is 3, because we are considering 2 raised to power n minus 1 here. Okay, so which means 3, and the number of combination are 2. So as you can see, if we check for 3, the number of combination can be formed are 2, And for your better understanding, I have painted the output as red, which satisfies the condition, and which doesn't satisfy the condition I have painted as black. Okay, so we can say that if we want to find the number of combination, we can just use this simple expression, which is 2 to the raised to power n divided by 2, which will give us the number of valid integers. Okay, but the problem arises here. As you can see, we have given 2 to the raised to power n, and the value of n can vary from 1 to 10 to raised power 5. And if you want to calculate 2 to the power 10 to raised power 5, which means 2 to the power so as you can see, this is an overflow condition, which means if you doesn't optimize the solution, you will get an TLE, which is time limit exceeded. So to optimize this solution, Geeks for Geeks has given us an amazing function to solve this problem. Okay guys, from now onward, I want your full attention so that you can know what we are doing here. Okay, so as I have told you, 2 raised to power 10 raised to power 5, which is 2 raised to power 1 lakh, which is quite a big number, and at that big number we can't perform the operations. So to optimize this solution, we need this function so that we can calculate the value of this expression only. Okay, but the big advantage of this expression is that it can perform both tasks at the same time, which means it can find out the value of 2 raised to power n, as well as it can modulo the output by this number. Isn't it amazing? And these all operations are done in very low time complexity, so that's why we have to use this function so that we can achieve our answer. I will tell you later on the working of this function, but for now I will be coding that problem. So let's begin. So as you can see, I have written the code. So let's now save it and compile it. See what will happen. Let's say number of test cases is 5. Then first give 1 as an input. Okay, 2 as an input. Man, that's not good. Okay, I got it. Return this. We have to assign the value of res as 1. So let's run it, compile it. So as you can see, our code has run and compiled successfully, and it is giving us the correct output. And let's run it for larger values. So as you can see, our code is running absolutely fine. So now you might be thinking what this whole piece of code is doing, Naveen. Please explain this to us. So okay, I will explain it to you what this whole piece of code is doing right now. So what it is doing, it is calculating the value of power, as well as it is doing modulo of the output, which will be the resultant output. So let's see how it is working. So first we are passing 3 parameters. So x here is 2, which came from here, 2 raised to power n, okay, and n minus 1 is the value of n, as you can see over here, value of n, okay, and mod is the value of this number by which we have to do modulo of the resultant output, okay. So let's see what will happen. So first, when I give the input as x and mod, here x is 2, n is 100, and the value of mod will be 20. Let's consider it 20, otherwise it will never satisfy the condition and you will never let to know what just happened in this piece of code. So let's see what is happening. So first we have initialized a res integer by 1, which will be a resultant output, and we are using a loop over here, and we are checking if the value of n is greater than 0 or not. If it is greater than 0, then execute this whole piece of code. If it is less than 0, then just return the value of res, okay. So first it came here and checked n modulo 2 is not equal to 0 or not. If it is equal to 0, then do not run this code, run this code, okay. So as you can see, first, and then we divide the value of n by 2, which means it will be left as 50, and then we perform this operation in which we are multiplying x by itself, and we are calculating the modulo 2, and then we are passing the value of this expression into the x. So our value of x is 2, so x into x is equal to 4, and x into x modulo 20 is also equal to 4, because if we want some change in the modulo, then the value of x should be greater than 20, okay. And by this our first loop has executed successfully, and the value of n now is left over only 50. And now it checked again if n modulo 2 is not equal to 0 or not. If it is equal to 0, then it executed this line of code and it divided by 2, and the value of y become 25, okay. And this piece of code executed again, and the value of x into x is 16, and the value of x into x modulo p, which is mod over here, which is mod over there, okay, its value is 16, okay. So the code run again, so it executed the loop again, and it checked again if n modulo 2 is not equal to 0 or not, and this time the condition satisfied and it executed this piece of code, okay. So what happened here, it multiplied the value of res, which is 1 from the initial, and it multiplied by the value of x, which you can see over here, which is 16, and the value of res becomes 16, and it gets stored in the res integer variable. And then we executed this piece of code again, and the value of n become 12, because if we divide 25 by 2, it will be 12.5, and we are storing it in an integer variable, so we consider always the lower value, which is 12. So this piece of code executed again, and now the value of x becomes 256 because 16 into 16 is 256, and if we do 256 modulo 20, its resultant output will be 16. Okay, and this code will keep on executing till we reach the value of n as 0, and when the value of n is equal to 2, it will exit the loop and it will return the value of res as 16. Okay, so now I think you have got the idea how this piece of code is working. But I think so you still have a doubt why we are passing here n minus 1, because I have told you earlier we have to divide 2 raised to power n by 2, which means 2 raised to power 100 by 2, and which is equal to 2 raised to power 99. Okay, so by this small change we are saving the time for this operation, which will be result equal to result divided by 2 if we didn't pass the value of n as n minus 1. Okay, so this is a useful tip for you too, and let's run our code for this same input too. Okay, so here the value of mode will be 20, and the rest of all will be same. So let's run our code. The number of query will be 1, and the value of n will be 100, and as you can see over here the output is 8. So now you will be saying that Naveen, the output here is 100. Let me explain. The value we are passing over here is 100, and value we are passing over here is 99 if we see over this code piece of code. And if I change this value to n and save this code and run this code again, you can see the value of x is 16. Okay, so now I think you have got the idea how to approach this problem. So now we are going to copy this code and paste it in the code chef. So as you can see over here, our run has compiled and run successfully, and we have got a score of 100%. So that is it for today guys. I hope you like this video. If you do, please make sure to hit that like button. It really motivates me, and if you hit the like button, the YouTube algorithm will push this content to more and more people. So please make sure to like this video, and if you think that my solution is the best, then please make sure to subscribe my channel and hit that bell notification icon so that you can get notified for my upcoming amazing videos like this. And I will see you in next video. Bye bye.